Look up. Everything you've ever known is right there. A tiny speck of light. Now turn your back on it. Leave home. Leave the solar system. Leave the galaxy. There's only one question that matters out here. How far are you willing to go before you stop being afraid? To feel the fierce heat of burning stars, face the force of violent cosmic collisions, dodge Death Stars and insatiable supermassive black holes, witness the birth of new stars, and reach the limits of human understanding. It means going back in time to the beginnings of the universe, to see for ourselves the moment it all began, the Big Bang. Are you ready? Then let's go on a journey to the edge of the universe, the edge of space. Only 100 kilometers up, just an hour's drive from home. Down there, life continues. The traffic keeps moving. Stocks go on trading. At this rate, Star Trek is still showing the bloopers. Would the honorable gentleman resume his seat? Mr. Ash. But we have to leave all this behind to dip our toe into this vast dark ocean. Beyond, into the shallows. Not too far from home, onto the moon. It's about 400,000 kilometers from Earth. 3 days in a spacecraft, reassuringly close to home. Dozens of astronauts have come this way before us. 12 of them have walked on the moon itself. It looks like a deserted battlefield, bombarded by millions of meteoroids and asteroids. But it's quieter now. It's obvious there have been no major collisions for millions of years. The Apollo 11 lunar module has landed. That's one small step for man. For the Apollo astronauts, the risks were high. Finally here, beautiful. But the rewards were higher. To see our planet as it had never been seen. To step where no human had stepped before. To visit another world. A world blasted by the sun's deadly radiation. It's just endless, congealed lava piles of dull gray rocks. Go ahead. Oh, that view is tremendous. Go for it. During the Apollo missions, rocks like these were the ultimate souvenirs. The astronauts took hundreds of them home for scientists to analyze. Turns out, these dull gray rocks aren't so dull after all. Like us, they've come here from Earth. NASA's scientists discovered the rocks had been superheated, evidence of a massive explosion. The explanation, 4.5 billion years ago, a stray planet smashed into Earth. It blasted billions of tons of molten rock out into space, and this came together to make the moon. It's a strange thought. The moon, made from the Earth, perfectly setting up the flag now. Beautiful. Just beautiful. Neil Armstrong's first footprints look like they were made yesterday. There's no wind here to cover them with dust. They should survive for millions of years, maybe longer than us. Our time is limited. We need to take our own giant leap further than any human has ever traveled. Out of the darkness, a friendly face, the goddess of love, Venus. The morning star, the evening star. Venus is the solar system's brightest planet. Its spectacular yellow clouds reflect the sunlight. A sister to our planet. She's about the same size and gravity as Earth. It should be safe here. But the Venus Express space probe is telling us these dazzling clouds are made of deadly sulfuric acid, that the planet's atmosphere is choked with carbon dioxide. It's ringing alarm bells. Venus is an angry goddess. The air is noxious, the pressure unbearable, and it's hot, approaching 500 degrees. Stay too long, and we'd be corroded, suffocated, crushed, and baked. Nothing can survive here. Like this. It's a Soviet Venera robotic probe. Its heavy armor has been wrecked by the extreme atmosphere. So lovely from Earth. Up close, Venus is the sister from hell, pockmarked by thousands of volcanoes. All that carbon dioxide in its atmosphere is trapping the sun's heat. This is global warming gone wild. Before it took hold, maybe Venus was calm, more like her sister planet, Earth. If that's true, this could be our planet's future. A future shaped by the sun. There's something hypnotic about it, like Medusa. It's too terrible to look at, too powerful to resist, luring us onwards, like a moth to a flame. Dwarfed by, scorched by the sun. It's Mercury. Get too close to the sun and this is what happens. Temperatures swing wildly here. At night it's minus 170 degrees. Come midday, it's 400 plus, burnt and frozen. And look at those scars. Seems Mercury had a violent past. The Messenger space probe, it's telling us something strange. For its size, this little planet has a powerful gravitational pull. It must be heavier than it looks. It's like a huge ball of iron covered with a thin veneer of rock. The core of what was once a much larger planet. So where's the rest of it? Maybe a stray planet slammed into Mercury, blasting away its outer layers. Everything is telling us to turn back. But who could defy this? The sun, in all its mesmerizing splendor. Our light, our lives. Everything we do is controlled by the sun, depends on it. Throughout history, across cultures, it's the pivot around which life on Earth revolves, nurturing our crops, structuring our days, inspiring our beliefs. 150 million kilometers from home, a 20-year journey by plane. Switch it off, and it's so far away. We wouldn't know about it for a whole 8 minutes. It's so big you could fit 1,000,000 Earths inside it. So heavy, its gravity controls the entire solar system. We see it every day, a familiar face in our sky. Up close, it's unrecognizable, a turbulent sea of incandescent gas. The thermometer rises to over 5,000 degrees. Down in the core, it's got to be tens of millions of degrees. Hot enough to trigger a nuclear reaction, turning millions of tons of matter into energy. Energy, every second, more than all the energy ever made by mankind. Back home, we see this energy as light, feel it as heat. But up close, there's nothing comforting about the sun. It's so full of electrical and magnetic activity, it's bursting out in these huge incandescent gas loops called prominences, each one releasing more energy than 10 million volcanoes. You could fit the Earth through one of these loops and still have tens of thousands of kilometers to spare. And where they burst through, it's exposing the cooler layers below, making sunspots. They're a fraction cooler than their surroundings, which is why they look black, but they're still hotter than anything on Earth. And they're massive too. Some of these are at least 50,000 kilometers across. And nearby, a solar flare. A superheated stream of electrified gas blasting deadly radiation out into space. But one day, all this will stop. The sun's fuel will be spent. It will die, and so will life on Earth. The sun creates life and destroys it. It demands we keep our distance. This comet strayed too close. It's being boiled away by the sun's heat, creating a tail that stretches for millions of kilometers. It's freezing in here. There's no doubt where this comet's come from. The icy wastes of deep space. But look at all this steam and geysers and dust. It's the sun again, melting the comet's frozen heart. A kind of vast, dirty snowball covered in grimy tar. Tiny grains of what look like organic material preserved on ice since who knows when, maybe even the beginning of the solar system. Say a comet like this crashed into the young Earth billions of years ago. Maybe it delivered organic material and water, the raw ingredients of life. It may even have sown the seeds of life on Earth that evolved into you and me. But say it crashed into the Earth now. Think of the dinosaurs, wiped out by a comet or an asteroid strike 65 million years ago. It's only a question of time. Eventually one day, unless we can find a way to protect ourselves, we'll go the way of the dinosaurs. The Earth is safe for now, but if life on Earth was obliterated, we'd need to find another home. Among the millions, billions of planets, there must be one that's not too hot, not too cold, with air, sunlight, water. The red planet. Unmistakably Mars. For centuries, we've looked to Mars for company, for signs of life. Somewhere down there could be extraterrestrial life. But are we ready to find it? Ready to rewrite the history books? To tear up the science books? To turn our world upside down? What happens next could change everything. More than any other planet, Mars captures our imagination. Think of sci-fi films, comics. What follows? Martians. It's all just fiction, right? But what if there really is something here? If it is, it's living on a dead planet. The processes that make the Earth habitable shut down hundreds of millions of years ago. Here, red and dead, Mars is a giant fossil, a dust devil, a big one, bigger than the biggest tornadoes back on Earth. There's wind here, and where there's wind, there's air. Air that could sustain extraterrestrial life. But it's too thin for us to breathe, full of choking carbon dioxide. There's nothing to protect Mars from the sun's ultraviolet rays, and it's cold, as low as minus 80 degrees, freezing water in the ground, at the poles, and even in the atmosphere is snow. It's hard to believe anything could live here, but back on Earth, there are creatures that survive in extreme cold, heat, even in the deepest, darkest ocean trenches. Even in the most extreme conditions, life usually finds a way. But on a dead planet with no geological activity to replenish the minerals and nutrients in its soil, no heat to melt its frozen water, and all this dust, it's hard to see where we're going. Olympus Mons, a vast, ancient volcano, 3 times higher than Everest. There's no sign of activity. Since its discovery in the 1970s, it's been declared extinct. Any lava flows should be long dead, obliterated by meteorite impact, unless this monster isn't dead after all. If it's not, there could be molten magma beneath the crust right now. This changes everything. Volcanic activity could be melting frozen water in the soil, creating conditions for life to exist. This makes the Grand Canyon look like a crack in the sidewalk. It goes on and on. So far it would stretch all the way across North America. And there are signs of erosion, of dried up riverbeds, as though volcanic activity melted ice in the soil, sending water flowing through this canyon. Activity that we now know could still be creating water. And where there's water, there could be life. If we can find running water, there's a chance we could find living creatures. The hunt is on. Trundling across this desolate landscape, the NASA rover Opportunity is finding evidence that these barren plains were once ancient lakes or oceans that could have harbored life. And look at these. When probes orbiting Mars pass over these gullies, they keep spotting new ones. More proof that Mars is alive and kicking, that there may be water flowing beneath its surface creating these gullies. Water which could be sustaining Martian life. Now all we have to do is find it. Unless we've already found it. Not on Mars, but on Earth. It sounds crazy, but there's a theory that life started here before moving to Earth. The idea is that an asteroid impact blasted fragments of Mars, complete with tiny microbes, out into space and onto the young Earth, where they seeded the seeds of life itself. No wonder we find Mars fascinating. It could be our ancestral home. If it's true, it means we're all Martians. The Mars we thought we knew is gone, replaced by this new, active, changing planet. And if we don't know Mars, possibly the solar system's most studied planet, what else don't we know? There must be other secrets out there waiting to be discovered. This is like being inside a giant video game, but these are all too real. Asteroids. Some of them hundreds of kilometers wide. This one must be about 30 kilometers long. And look, it can't have been easy parking a probe on an asteroid traveling at 880,000 kilometers an hour. It's a lot of effort to investigate some rubble that regularly collides, breaking up and raining down on Earth as meteorites. But it turns out it was rubble like this that came together to make the planets, including our own. So by dating the meteorites we find on Earth, we know the planets were born 4.5 billion years ago. These are the birth certificates of our solar system. But for some reason, these rocks didn't form into a planet. Something must have stopped them. Something powerful. Jupiter. What a monster. At least 1,000 times bigger than Earth. So vast you could fit all the other planets inside it. Something this big is going to have a major effect on its neighbors. Its gravity is stopping the asteroids from forming a planet. But this huge planet is almost all gas. Land here and we'd sink through its layers, probably never hitting a solid surface. And Jupiter's good looks are the product of extreme violence. It's spinning at a huge rate, whipping up winds to hundreds of kilometers an hour, contorting the clouds into stripes, eddies, and whirlpools. And this, the legendary Great Red Spot, the biggest, most violent storm in the solar system, at least 3 times the size of Earth. It's been raging for over 300 years. All those churning clouds have sparked an electrical storm. Just one bolt is 10,000 times more intense than any at home. It seems the best place The safest place to see Jupiter is from a distance. Look at those lights. They're like the aurora back home dancing around the poles. But the Geiger counter is going wild. It seems even these are deadly, generated by lethal radiation pulled from space by Jupiter's powerful magnetic field. We're beginning to realize out here, nothing is what it seems. The universe is full of contradictions. We have to proceed with caution, weaving through the paths of Jupiter's 62 or more moons. This multicolored moon is called Io. Those pretty colors are molten rock, sulfur volcanoes spewing burning hot ash for hundreds of kilometers into the air. This is the most volatile place we've seen since the sun. Our magical journey to the edge of the universe is turning into a desperate flight. We've got to keep believing, hoping that amidst the dangers, there are safe havens out there somewhere. 650 million kilometers from home. What a weird-looking place, and yet it seems strangely familiar. It's a bit like the Arctic with all that ice, all those ridges and cracks. This is another of Jupiter's moons, Europa. And maybe, like the Arctic, this ice is floating on water. Liquid water. It's an intriguing thought. But we're 800 million kilometers from the sun. Surely Europa is frozen solid. Unless Jupiter's gravity is creating friction deep inside, stopping Europa from freezing solid, allowing life to develop in the waters beneath its frozen crust. We might be meters away from aliens, from a whole ecosystem of microbes, crustaceans, maybe even squid. The only thing between us and the possibility of alien life is this layer of ice. But until we send a spacecraft to drill through the ice, Europa will remain one of the solar system's greatest mysteries. It's captivated our imaginations, haunted our dreams, and here it is, spinning before our eyes. Saturn, the jewel in the solar system's crown. Seeing it makes everything we've experienced worthwhile. There's something magical about Saturn, a giant ball of gas so light it would float on water. Its spectacular rings which stretch almost from Earth to the moon, but they're just a few hundred meters deep. The Cassini orbiter is picking up ghostly radio emissions, probably generated by auroras around Saturn's poles. This is the real music of the spheres, and it's telling us these rings are most likely all that's left of a moon shattered by Saturn's gravitational pull. Incomparable beauty from total destruction. Billions of shards of ice, some as small as ice cubes, others the size of houses. They collide, break apart, reassemble. It's like a snapshot of our early solar system as dust and gas orbited the newly born sun and gravity worked its magic, pulling the lumps together until, from debris like this, our home emerged. Every object orbiting Saturn is technically a moon, from the smallest block of ice to the planet's 60 or more larger moons, including one that's larger than our moon, larger even than Mercury. Titan. It's wrapped in thick clouds. But beneath the clouds, it seems like there's an atmosphere. Down here there's wind, rain, even seasons. And look at these rivers, lakes, and oceans. It's the most similar place to Earth we've seen so far. Except that's not water. That's liquid natural gas. There must be hundreds of times more natural gas here than all the Earth's oil and gas reserves. If we could get it home, it could power our cities, fuel our cars for thousands of years. Or huygens one day we could use it here to fuel a colony, assuming there isn't life on Titan already. The Huygens space probe dropped onto Titan's surface from Cassini is here to find out. It's telling us there are organic materials in the soil, but it's so cold, minus 180 degrees, there's no way these could come together to form life. Unless Titan warms up, the sun is predicted to get hotter. When it does, maybe life will spring up here just like it did on Earth billions of years ago. As the Earth gets too hot for us, maybe we'll move to Titan. One day, we might call this distant moon home. Home. We're at least 1 billion kilometers away now. Beyond this point, we lose visual contact with the Earth. It's as though we're standing on a cliff looking out into the solar system's mysterious outer reaches. If we want to understand the universe, to reach its edge, we have to jump. Unseen from Earth, unknown for most of history, were the solar system's outer reaches. It's like diving down into the deep ocean. Those rings. It looks like Uranus has been tilted off its axis, toppled over by a stray planet. It's eerie out here. Lonely. But we've barely left the shore. Shrink the Earth down to the size of a pea. We've traveled less than 2 kilometers. But to reach the edge of the solar system, we've got to travel another 20,000 kilometers. Out of the deep, another strange beast. The god of the sea, Neptune. From a distance, it looks peaceful. But look at that spot. It's a vast storm the size of Earth, whipped up by savage 1,500 km/h winds. Back home, it's the sun that drives the wind. But Neptune's too far away. Something else must be creating these ferocious winds, but nobody knows what. And just beyond, one of Neptune's moons, Triton. Just look at these geysers, cosmic chimneys pumping out strange soot. And this moon is going round Neptune in the opposite direction to the planet's spin. A cosmic battle of wills that this angry moon is always going to lose. Neptune's massive gravity is pulling on Triton, slowing it down, reeling it in. One day, it'll be ripped apart by the god of the sea, and that's it. No more moons, no more planets to see in our solar system. But look at all this. It's not empty. It's teeming with frozen rocks, icy spheres, like Pluto. Until recently, it seemed Pluto was alone. Beyond it, nothing. We were wrong. More frozen worlds. Discoveries so new, nobody can agree what to call them. Plutinos, ice dwarfs, cubawanos. Whatever the name, the implications are the same. Our solar system isn't the neat model we thought it was. Over 13 billion kilometers from home, the most distant thing ever seen, to orbit the sun. Another small, icy world called Sedna, discovered in 2003. Its orbit takes 10,000 years and sends it 130 billion kilometers from the sun. There's something else out here. 16 billion kilometers from home, the space probe Voyager 1. If it wasn't for this, we'd have no images of the giant planets, no clue about their strange moons. That gold panel, it's a kind of intergalactic message in a bottle. There's a greeting recorded in different languages. Hello from Earth, and a map showing how to find our solar system. But if you're in the jungle, is it wise to call out? Anyone, anything could hear our call, find out where we live, and come knocking. Friendly or not, a cloud of cosmic icebergs. They look like the comet we saw earlier. Perhaps it started life out here just like the comets that may have planted the seeds of life on Earth billions of years ago. And seeing all this ice, maybe they carried water to Earth too. The water in the oceans, in your coffee, even in your body, all from this distant celestial ice machine. We're 8 million, that's 8 trillion kilometers from home. But our journey has only just begun. Ahead, trillions of kilometers, billions of stars. This is it. Time to step out into the big, wide universe, into interstellar space. Interstellar space? Far beyond our solar system? What a view. Billions of stars like our own sun, many with planets, many of those with moons. It's hard to know which way to go. There are infinite possibilities in every direction. Whichever way, we're going to need a serious burst of acceleration. 40 trillion kilometers from home, a 150,000-year ride in the space shuttle, and we've only just reached the first solar system after our own, Alpha Centauri. 1 star and 2 more beyond. They're spinning around each other, locked in a celestial standoff. Each star's gravity attracting the other, their insane orbital speed keeping them apart. We're so far from home now that kilometers are becoming meaningless. We're going to have to talk in light years. A beam of light takes 1 year to travel 10 trillion kilometers. So 40 trillion kilometers is over 4 light years from home. It's crazy distances, so vast they're almost beyond comprehension, and exciting. Who knows what strange worlds lie ahead, what we'll discover when, if, we reach the edge of the universe. 10 light years from Earth, the star, Epsilon Eridani. Spectacular rings of dust and ice, and somewhere in there, planets forming out of the debris, being born before our eyes. Asteroids and comets everywhere. We could almost be looking at our own solar system billions of years ago, with comets delivering organic molecules and water to these young planets, kickstarting life just as they may have done on Earth. At the center of all the action, a star smaller than our sun. It's still in its infancy. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here, but finding them is like looking for a needle in a cosmic haystack. 20 light years from Earth, star Gliese, 581. It's about the same age as our sun. And orbiting it, this planet, it's just the right distance from its sun. Any closer and water would boil away. Any further and it would freeze. Ideal conditions for life to have evolved. And if comets have struck, delivering water and organic materials, then life, complex beings like us, even civilizations like our own, could be down there right now. If there are, even at this distance, they could be tuning into our TV signals, watching shows from 20 years ago. That's how long they would take to get here. And here's your host, Joe. But until future generations can find a way of communicating over these vast distances, all we can do is speculate. Us and them living parallel lives, unaware of each other's existence, unless life has been and gone. That's the problem with comets. They're creators and destroyers, as the dinosaurs found out the hard way 65 million years ago. This is the needle in the cosmic haystack, the closest we've come to a habitable solar system like our own. But it's a chance encounter. There could be hundreds, millions more solar systems like this out here, or none at all. It's Algol, the demon star, feared since ancient times. From Earth, it appears as one star that flashes on and off. But up close, we can see in reality it's two stars, and one is being sucked towards the other, almost 100 light years from home. Listen, one of the first ever radio broadcasts, just a faint whisper. We'd appreciate it if anyone hearing this broadcast would communicate with us. We are very excited to know how far the broadcast has reached. And then silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. It feels like a lifetime ago we looked up at the sky wondering where we fit in. Now we're learning to appreciate the wonders we're seeing, not just for what they tell us about our own world, but what they can tell us about the whole universe, its past and its future. Deep inside our galaxy, the Milky Way, a vast celestial library. Each star, a book with a story to tell. The Seven Sisters. From Earth, this is the brightest star cluster in the sky. And this giant Betelgeuse, the brightest, biggest star we've seen so far. At least 600 times wider than our sun. But this, it's not a star, not a planet, not like anything we've ever seen. A ghostly specter more than 1,300 light years from Earth. Orion's dark cloud, dust and gas so dense it's shrouding us, shutting us off from the universe outside. There, deep inside, a ball of light pulling the dust and gas towards it, heating it up, merging into a ball of burning hot gas like a star, like our sun in miniature. Inside, temperatures reach millions of degrees, so hot it's beginning to trigger nuclear reactions, the kind that keep our sun shining, making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We came here expecting horrors. Instead, we've discovered one of the universe's greatest wonders, starbirth. Jets of gas exploding outwards at 200,000 kilometers an hour, blasting dust and gas out from millions of kilometers. It's unbelievably violent. But look at the results. Nebulae. Vast, glowing clouds of gas hanging in space. With no wind out here, they'll take thousands of years to disperse. We've seen some strange sights, but this, it's a masterpiece. A giant horse's head rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night? Or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light years further. Luminous clouds suspended in space. encircling what was once a star like our sun. All that's left of it are these brightly colored gases, elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, it was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins here. At its heart, the ghost of a star. It's a white dwarf. White hot, small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it will become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone, stories left untold, celestial books lost forever. But the greatest story of them all is still to be told. We must go back through time to the very first chapter to tell the story of how the universe began. The scattered remains of a dead star, a nebula, the Crab Nebula. We are 6,000 light years from home, deep inside a stellar graveyard. Dust and gas stretching for trillions of kilometers. It looks dead, but maybe this is just the calm after the storm. After a massive explosion powerful enough to turn a huge star into a cloud of dust and gas. A supernova. Here it is, the eye of the storm. A spinning, pulsating star. A pulsar. Gravity must have squeezed the giant star's core down to this. It's just 20 kilometers across, making it unimaginably dense. One pinhead of this would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater spinning on the spot with arms outstretched then pulling them in, it began to spin faster. 2 beams of light, energy, radiation spinning 30 times a second, powering the huge cloud of dust and gas. There's so much radiation here, even more than on the sun. If this pulsar got as close to Earth as our sun, our planet would be instantly stripped of life. That was easily the deadliest thing we've encountered so far. Getting a strange sensation, a feeling as though there's something bad out here. A malevolent presence. The one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We're staring into the face of death. The remains of a giant star. A black hole. Instead of contracting to a white dwarf or a pulsar, it just kept on going, shrinking until it got so small it's just a few kilometers across, far denser than a pulsar, and impossible to resist. Strayed too close, and there's no turning back. Now we know why it's a black hole. Its gravity is so intense not even light can escape. This asteroid, a lump of solid rock, is stretching, being dragged towards the gaping hole. Inside, there's no matter as we know it, no time, no space. All the rules of physics collapse. The asteroid is gone. Truth is, nobody really knows what we're looking at. This is the limit of human understanding. There could be millions of black holes creeping around our galaxy, more perhaps than all the stars in the sky, but we wouldn't see them until it was too late. Like this star, spiraling, disappearing down an invisible sinkhole. Who's to say we don't live inside a vast black hole? That the whole universe isn't inside one right now? Inside another universe? Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we're still in our own galaxy, the Milky Way. The rest of the universe still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we've got to find a way out of the Milky Way. 7,000 light years from home, still deep inside our own galaxy. It's as though we're in a forest thick with trees, each so beautiful, so fascinating, it's impossible to look beyond to see the bigger picture. We have to find a way through, reach the clearing at the galaxy's edge. Only then can we begin to understand where it, and we all, began. But faced with sights like this, it's hard to leave. A colossal, glowing cloud topped by these great towers of dust. the pillars of creation, like a gateway into the far galaxy. Both pillars are studded with tiny bulges, embryonic star systems, each one the size of our solar system. It's another monument to nature's astonishing creativity. But we have to ignore its captivating beauty, tear ourselves away, to carry on towards the edge of the galaxy. Dazzled by the Milky Way's beauty, we've strayed into a cosmic minefield. Like an explosion in slow motion, giant clouds of gas bursting out of this star. A star millions of times brighter than our sun. The nuclear reactions that power it are winding down. We're watching its death throes. And beyond it, an even bigger, even more dangerously unstable star. But this one's about to explode. And when a star this big dies, it's 100 times more violent than a supernova. Somehow we've stumbled into the most violent star death imaginable. A hypernova. The core has collapsed. It's becoming a black hole. And that's the shockwave surging through the star, ripping its outer layers into space. There's lethal radiation everywhere, enough to have a catastrophic effect on any planet unlucky enough to be nearby. When virtually every species on Earth was wiped out 450 million years ago, the culprit may have been one of these deadly hypernovae. Frozen comets, scorched planets, white dwarfs, red giants, Earth, tiny drops in a vast pool of white light. Our home galaxy, the Milky Way. We wanted to know where we fit in. Here's our answer. Civilizations past and present, everyone that's ever lived. The smallest bug, the highest mountain. All of it invisible, not even a tiny speck. Our home is a minor planet of an insignificant star. If it disappeared right now, we wouldn't even notice. And yet, so far, we've found nowhere else we would rather live. Nowhere we could live. It's only now, far from home, that we can truly appreciate it. But look at all these stars, hundreds of billions of them. Surely one of these, more than one, must be capable of supporting life. Maybe here in this swarm of stars, the Great Cluster. Back in the 70s, astronomers sent a message in this direction detailing the structure of our DNA and showing the plan of our solar system. But it's so far from home, the message won't arrive for at least another 25,000 years. We haven't found alien life yet, but neither have we found any reason to believe it isn't out here somewhere. There's an equation devised to estimate the number of other advanced civilizations, and the result is shocking. There should be millions of civilizations just in our galaxy. Everything we've seen so far is inside the Milky Way. Now here's our chance to see other galaxies, to glimpse the even bigger picture, and perhaps to answer the ultimate question. Where does all this come from? It's time to leave our galaxy and enter intergalactic space. Beyond the Milky Way, through the vast expanse between galaxies against all the odds, we've made it to intergalactic space. Out here, there's no horizon in sight. Even the closest galaxies are hundreds of thousands of light years away. The remains of galaxies ripped apart by the Milky Way's huge gravitational pull, scattered through nothing. This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else. Dark matter. So mysterious we can't see it, feel it, taste it, touch it, or even measure it. Yet so common, it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there's no such thing as empty space. Even out here, we're surrounded by matter. We only suspect it exists because of the strange hold it seems to exert on galaxies like this one, the Large Magellanic Cloud. More than 6 billion years in today's fastest spacecraft, 160,000 light years from the Milky Way, at the edge of its gravitational reach. This galaxy should spin off into space, but something seems to be holding it here. Something invisible, powerful, dark matter, stars, clusters of stars, nebulae. It's a vast astronomical treasure house. But look at this. It's like a string of gleaming pearls, a fireball expanding out from what must have been a massive explosion. A supernova so bright that when light from the explosion reached Earth in 1987, it was visible with the naked eye, and so violent it triggered a string of nuclear reactions, forcing atoms together, creating new elements, gold, silver, platinum, blasting them out into space. The gold in the ring on your finger was forged in a massive supernova like this, trillions of kilometers away, billions of years ago. Before we left home, the universe seemed separate. We were wrong. The universe is part of us. We are part of the universe. It's comforting to remember as we venture through this abyss, further and further, faster and faster. The Andromeda Galaxy, 2.5 million light-years away. It's moving through space at nearly 1 million kilometers an hour. Everything in space is moving apart, like shrapnel from an explosion. We're seeing this galaxy as it was when our ape-like ancestors first walked across the African plains. There's order in this chaos, a path behind the infinite variety, an endless cycle of birth and death, creation and destruction. It's a pattern woven through the vast fabric of space that binds each of these galaxies. There are billions of galaxies in the universe, each with billions, even trillions of stars. Possibly more stars than there are grains of sand on all the beaches on Earth. And all these are just the stars that exist now. What about all the stars that have been and gone, all the stars being born, yet to be born? We're finally beginning to see the big picture, and it's bigger than we ever imagined. This galaxy, the huge Pinwheel Galaxy, is so far from Earth that if we send a message home now, it will take 27 million years to get there. Who knows whether our species, our planet, will still be around to receive it? We travel on, back through time, past the point where the dinosaurs were wiped out, past the moment where the first creatures clambered onto land. 2 billion light years from home, closing in on the edge of the universe, going back to the beginning of time. This isn't a galaxy. It's brighter than hundreds of galaxies put together. A blinding beam of energy bursting out for trillions of kilometers. Something this big, this bright, must be incredibly powerful. Experience tells us out here, power equals danger. It looks like a quasar, the deadliest thing in the universe. If it is, then our journey could be over just as the end is almost in sight. The deadliest, most powerful thing in the universe. A quasar, a swirling cauldron of superhot gas, brighter than hundreds of galaxies. The source of this awesome power lies deep inside the heart of the beast. A heart of darkness. A supermassive black hole, as heavy as 1 billion suns. It's ripping apart whole stars, sucking their gases into the quasar, devouring them until they're nothing, lost forever from the visible universe. We've seen the worst the universe can throw at us, its most powerful, destructive forces. Now our path is clear. The very edge of the universe is almost within reach. But we still need to go further, faster, if we're to cross the final reaches of the universe. 8 billion light years from home. More galaxies. But these look different. Ragged, small, close together. We're so far back in time, we're seeing these galaxies as they were before the Earth was even born. They're still young, still growing. We are getting closer to where and how it all began. 12 billion years ago. Look at the galaxies now. They're more like primitive plankton floating in a vast dark ocean. It's magical. Clouds of dust and gas dancing, forming shapes, merging to make embryonic galaxies. This is how our own galaxy was born. They're disappearing. We've gone back before the stars were born, into a cosmic dark age. And before that, light. The afterglow from a massive explosion. The explosion which created the universe. We're almost there. This is it. We've made it. The edge of the universe. 130 billion trillion kilometers from home. 13.8 billion years ago. The very instant of the Big Bang. The most violent, most creative moment in history. Everything that's ever happened follows from this moment. Every religion, every culture has pondered it. But we still don't know what sparked this act of creation, or why. This is where our journey ends and the universe begins. The edge of the universe. 13.8 billion years ago. At the single most important moment in history, the beginning of history itself. An infinitely hot, small, dense point erupts. The Big Bang, creating space, time, matter, our universe itself. Our universe. First, it's the size of a subatomic particle. The tiniest fraction of a second later, it's big enough to hold in the palm of your hand. Moments later, it's the size of the Earth. Today, the light from the Big Bang is still spreading out as a hiss of radio static. Your TV aerial picks it up. You can see it as static on an untuned TV. We go on, forwards through time. All the things we've seen on our journey are sparks flying out from the Big Bang. Galaxies, stars, planets, all just debris. Back through our galaxy, our solar system, until we reach another cooling cinder swirling in the afterglow of the Big Bang. The Earth. After a 260 billion trillion kilometer journey, we're back here. Home. A single pixel of dust in a sea of fire. Yes, it's small. Yes, it will die. But we are the universe that woke up. We looked into the abyss and understood it. We reached the edge and came back to tell the story. So don't look down at this world with sadness. Look up with pride, because the rarest thing in all of existence is standing right here. Us.